Good day, everyone. Today we'll explore something that's literally beneath our feet. It is soil. It might look simple, but soil is a complex and vital layer that supports all life on land. In this presentation, we'll take a closer look at its structure and the different layers that make it up. Let's start by understanding what soil actually is. For For the lesson objectives, you should be able to describe what soil is and how it forms, identify and explain the different soil layers or horizons, recognize the importance of each layer in supporting life, appreciate the role of soil in the environment and human survival. Now that we know that we're talking about something more than just dirt, let's start by understanding what soil really is, where it comes from, what it's made of, and why it's important to life on Earth. So, what is soil? Soil isn't just dirt, it's a living system that supports plants, animals, and humans. It forms over thousands of years through rock weathering and the action of organisms. It is a combination of mineral, organic matter, water, and air. So, what makes a soil good? What is a good soil? A good soil is composed of 45% mineral matter, 25% water, 25% air, and 5% organic matter. Without mechanical and chemical weathering, that was our previous lesson, without these kinds of weathering working to break down rock, there would not be any soil on Earth. It is unlikely that humans or most other creatures like animals or plants and humans would be able to live on Earth without soil. Um, Daily, ordinary things or the things that you have now, just like wood, paper, cotton, and even medicines, and water, they need soil. So, soil is a precious resource that must be carefully managed and cared for. Although soil is a renewable resource, its renewal takes a lot of time. Remember that soil is an essential resource that supports plant life, which in turn supports animal life. Um, it's more than just dirt. It's the foundation of ecosystems, agriculture, and even our food supply. Now that we know how important soil is, let's dig deeper into what it's made of and how its layers differ. So when we talk about soil horizon, we mean vertical section that shows its layer. Each of these layers is called horizon. By studying them, scientists can tell how the soil was formed and how fertile it is. In short, horizons or profiles reveal the story of the soil beneath us. Let's take a closer look at these horizons, one layer at a time. Before that, let's talk about how is it formed. So how these soil horizons form. So when rain or melting of snow infiltrates the ground, it carries down fine particles like silt and clay, along with minerals and organic acids. Over time, this downward movement, we call that translocation, creates distinct layers that differ in color, texture, and composition. That's why each horizon looks or even reacts differently. Now let's explore each of these horizons and see what makes them unique. There are a total of six soil layers. From the top, we have O horizon, A horizon, E, B, C horizon, and the R or the bedrock. The O horizon is made up of organic matter, such as leaves, needles, twigs, and moss. It is often thin, but it can be thicker in forests and other areas with a lot of vegetation. This is where nutrients start building up. Below that is the A horizon. The A horizon is the topsoil. It's made up of mixture of organic matter and mineral particles. The O horizon is where most of the plant root grow, and it's the most productive layer. Farmers depend on it since this is rich in nutrients and organic matter. Next is the E horizon. It is also known as the zone of eluviation. E stands for eluviation and leaching. This layer contains mineral particles that have lost much of their nutrients and organic matter as water carries them downwards. It's usually light in color, and it's often found in sandy soils and very little organic matter. Below is the B horizon. It's also called as the subsoil. It lies just below the A horizon and containing less organic matter where ions and clays leach from the A and the E horizon accumulate. Next, we'll move deeper to the C horizon. The C horizon is known as the parent material of the soil. It's made up of loose or partially broken rock and sediment. This layer hasn't been much affected by soil forming processes yet, but it serves as the foundation from which the upper layers develop over time. And finally, beneath it all, we reach the R horizon. R horizon is known as the bedrock. It is solid rock that has not been weathered into soil. This is the base layer. Over long periods of weathering of this rock, it gives rise to the layers above it. Now that we've gone through each layer, let's wrap up what we've learned so far about soil and its horizons. To summarize, O horizon is where organic matter, this is the organic matter like a pile of leaves on the forest floor. A horizon is the topsoil like the dirt you garden in. E horizon, this is where leach materials are. And this is like the sand that washes away from the beach at high tide. B horizon is the subsoil like the clay that makes mud puddles. C horizon is the parent material like the rocks that are under the soil. And lastly, the R horizon, the bedrock, like the solid rock that forms the foundations of the earth. So why do we need to study soil layers? First, it helps in farming and conservation by showing us how to manage land sustainably. It also guides buildings and land use. It will help engineers, contractors know which areas are stable for construction. And finally, soil reveals Earth history, recording changes in climate and environment over time. So this is a picture showing you all of the horizons that so far we've talked about, from O to the bedrock. Here we can see two examples of soil profiles. Picture A is from South Dakota. The soil layers are well developed. You can clearly see the horizon separated by color and texture. In picture B, this is from Puerto Rico. The horizons are less distinct, showing how soil formation varies with climate, vegetation, and time. Here's an example of an oxysoil. An oxysoil is a type of soil found in rainforests that's rich in iron and aluminum. While these soils give strong support for large trees, they're not ideal for farming because most of their nutrients have already been washed away by heavy rainfall. And this is the iconic Angkor Wat. Angkor Wat is in Cambodia, and this was built using bricks made from local oxysols. When these soils are exposed to sunlight after trees are removed, they harden almost like a stone. That's why they're strong enough for construction, but they're not suitable for farming. Here are some other fascinating facts about soil. Did you know that there are more living organisms in a handful of soil than there are people on Earth? Soil takes hundreds to thousands of years to form just a few centimeters. Healthy soil can store more carbon than all the world's forests combined. And that's why we also categorize or include soil as one of the carbon sinks in this planet. What causes different types of soil to form? There are many different reasons. The first one is climate. Different rock types in a given climate will produce a similar soil. The next one is rock types. Minerals that are present in the rock determine the composition of the material that is available to make soil. The next one is the slope. The steeper the slope, the less likely material will be able to stay in place to form soil. If you are familiar with, I know you are familiar with areas prone to landslide, and these areas are steeper than any other areas. And if the slope is steeper, the less likely the material will able to stay in place to form soil because of the action of gravity. Next one is time. Time, it also affects soil formation. The longer the amount of time that soil remains in a particular area, the greater the degree of alteration of soil material. And lastly, biological activity. We know that plants, animals, every living organism can have a big impact in soil formation. The partial decay of plant material, for example, and animal remains, they produce organic material and nutrients in soil. Are you familiar with humus? Okay. Soil may look ordinary, but it's truly alive. Soil is a living system that supports all life on Earth. Each layer plays a vital role in plant growth and Earth stability. And caring for soil means caring for our planet's future. Every layer, from the surface to the bedrock, remember, has a purpose. When we protect the soil, we are really protecting life itself.